Have you ever stopped to look around you and count how many things are made of plastic? Your computer mouse, the pen on your desk, the container holding your lunch, maybe even the chair you are sitting on. Plastic is so common that we barely even notice it anymore. But have you ever wondered what it actually is and how we make this stuff that seems to be absolutely everywhere? Think about your daily life. You wake up and your alarm clock is plastic. You brush your teeth with a plastic toothbrush. You pour milk from a plastic jug into a plastic cup. It's an invisible part of our modern world. For engineers and designers, plastic is a dream material. It can be molded into almost any shape. It can be hard as a rock or flexible as a film, and it's incredibly lightweight and cheap to produce. But at the same time, we hear news stories about plastic pollution in the oceans and overflowing landfills. It seems to be both a miracle material and a massive problem all at once. To understand this paradox, we have to go on a journey. We need to become chemists for a few minutes and uncover the hidden science behind how plastic is born. Our story begins deep underground with a black, sludgy liquid that has been there for millions of years. This is crude oil, the remains of ancient sea creatures and plants. For most of human history, this substance was just a curiosity. But today, it is the starting point for thousands of products, including the fuel for our cars and, you guessed it, almost all of the plastic in the world. Crude oil itself is a messy mixture of all sorts of different molecules. It's not very useful in this raw form. To turn it into plastic, we first have to clean it up and separate its parts. This happens at a massive facility called an oil refinery. Think of it like a giant, super hot kitchen for chemistry. Here, the crude oil is heated to extreme temperatures inside a tall column. As the oil boils, it separates into different layers, just like how steam rises from a pot of water. The lightest parts rise to the very top, while the heaviest, thickest parts stay at the bottom. Each layer is a different type of fuel or chemical. We get gasoline for cars, jet fuel for airplanes, and asphalt for roads. But for our story, we are interested in one specific layer. This layer is called naphtha. It's a clear, flammable liquid that contains the perfect building blocks for making plastic. This is the raw material our plastic factory is waiting for. From the refinery, the naphtha is transported to another chemical plant. Here is where the real magic of creating plastic begins, through a process that changes tiny molecules into giant ones. Inside a massive chamber, the naphtha is blasted with superheated steam. This process is called cracking, and it does exactly what it sounds like. It breaks the complex molecules in the naphtha apart. When they break apart, they form much smaller, simpler molecules. These tiny individual molecules are the fundamental building blocks of all plastics. They are called monomers. Think of a monomer like a single, tiny Lego brick. By itself, it isn't very strong or useful. You can't build much with just one brick. The most common monomer created from naphtha is a gas called ethylene. It's a simple little molecule, but it holds the potential to become something much, much bigger. There are other types of monomers too, like propylene and vinyl chloride. Each one is a different shape and size of Lego brick, and by using different ones, we can make different kinds of plastic. So now we have a huge collection of these individual monomer bricks. The next step is to connect them all together. This is the most important step in making plastic. This process is called polymerization. The prefix poly means many. So polymerization is the act of linking many monomers together to form a long chain. Imagine you have a giant box of paper clips. Each paper clip is a monomer. If you start linking them one by one, you can create a long, strong chain. This is exactly what happens to the ethylene molecules. To make this happen, scientists put the monomers into a special container called a reactor. They add other chemicals called catalysts, which act like a coach, telling the monomers to start linking up. Under high pressure and temperature, the monomers begin to bond with each other, forming incredibly long chains. One chain can be made of thousands, or even hundreds of thousands of monomers all linked together. This giant new molecule, this long chain of monomers, is called a polymer. And that's what plastic is, a material made of long-chain polymer molecules. When we connect thousands of ethylene monomers, we get polyethylene. This is one of the most common plastics in the world, used for everything from plastic bags to shampoo bottles. These long polymer chains are like spaghetti. When you have a bowl full of them, they are all tangled up with each other. This tangled structure is what gives plastic its strength and flexibility. The chains can slide past each other a little bit, which allows plastic to bend and stretch without breaking, but they are also interlocked, which makes the material strong and solid. Once the polymerization reaction is done, the final product is a collection of tiny plastic pellets or powders. These are shipped to factories all over the world. At these factories, the pellets are melted down and then forced into molds, pushed through small openings to make fibers, or rolled into thin sheets. This is how we get the final plastic products you see every day. The amazing thing is that by changing the recipe just a little bit, we can create a huge variety of plastics with different properties. If we use a different monomer, like propylene, we get polypropylene. This is a tougher plastic used for car parts, chairs, and food containers that can go in the dishwasher. If we use a monomer called vinyl chloride, we get polyvinyl chloride, or PVC. This is a very rigid and durable plastic used to make pipes and window frames. By mixing different monomers or changing how the polymer chains are structured, chemists can fine-tune the properties of the plastic to be exactly what they need for a specific job. They can make it transparent for a water bottle, soft for a squeeze toy, or incredibly strong and heat-resistant for a part inside an engine. This is why plastic is everywhere. It's a chameleon. It can be engineered to be the perfect material for almost any task you can imagine. It's waterproof, which is great for bottles and packaging. It's an electrical insulator, which is perfect for covering wires, and it doesn't rust or rot like metal or wood. Most importantly, it's extremely cheap to produce. The raw materials are abundant, and the manufacturing process is very efficient. This made it possible for everyone to have access to products that were once expensive luxuries. So the reason plastic took over our world is simple. Scientists and engineers designed a material that was strong, lightweight, versatile, and incredibly long-lasting. They solved the problem of needing a material that could do everything. And in doing so, they accidentally created a completely new kind of problem. Let's pause and think about what we just learned. We take a natural substance, oil, and use chemistry to rearrange its molecules into brand new super long chains that nature has never seen before. And this brings us to the big insight, the core of the plastic paradox. The very superpower that makes plastic so useful is the exact same thing that makes it so harmful to our planet. We designed it to be durable. We engineered it to be resistant to water, sunlight, and decay. We made it to last for a very, very long time. The problem is that the tiny bacteria and fungi that break down natural materials like wood and leaves don't know what to do with these man-made polymer chains. They don't have the tools to eat them. So when a plastic bottle is thrown away, it doesn't just disappear. It sits there for hundreds or even thousands of years. The strength we engineered into it becomes a curse. So what can we do? The solution isn't to simply hate plastic. It's an amazing and important material that has saved lives in medicine and made countless technologies possible. The real solution starts with the science we just learned. By understanding that plastic is just a collection of polymer chains, we can find clever ways to reuse them through recycling, melting them down to form new products. And even better, scientists are now using this knowledge to invent new bioplastics made from plants that are designed to be broken down by nature. Understanding the problem is always the first step to building a better, more sustainable world.